Hello students, now let us come back to the second half of this subchapter where we look at the applications of trigonometric ratio. This time around we're going to look at three-dimensional spaces, right? So what happened is when we look at three-dimensional spaces, sometimes we can envision right angle triangles in them, and that allow us to make a lot of calculations in the model that we are presented with. So let's start with a simple example. Here we have one where we are looking at a pyramid, right? It shows a pyramid with a rectangular base, PQRS, and a vertex V vertically above R. So when it says it's vertically above R, we know that V and R actually form a 90 degrees right angle with the plane that is on the floor, right? So with that information, we can actually create a lot of right angles triangles, and that helps. Okay, so we are given the measurement as in stated here, and we want to find the angle VQR. So my advice to you right now is that sometimes when we look at the three-dimensional object, it's not that straightforward to be able to visualize which length goes where, right? So what we usually do and what we usually encourage is to take that information and we try to actually extract only what's essential. Basically, we want to sketch the right angle triangles that we are dealing with. So for every sub part of the question, we will probably be dealing with a separate right angle triangle. So in the very first part here, VQR, you want to find angle VQR, we will just sketch the triangle VQR, right? So when we look at VQR, when we sketch the triangle, we can see that we can create a nice little triangle like so, right here. Okay, so and that's what we can do. VQR on the side, and from here we have the measurements, 3 for VR and QR is 5 units, okay, centimeter in this case. Then we can calculate the angle quite in a very direct manner, right? So we got that is 3/5 opposite over adjacent, and that gives us 31.0 degrees with 1 decimal places, right? Now in second part of the question, they ask us to find VPR. Now VPR is a bit more tricky because when we draw VPR, right? Let me see. VPR, here. When we draw VPR, okay, it's actually drawn here. But what happened is the first instinct was to try to create a VPR, right? So when I create a VPR, and I will quickly realize that although I know the VR, I do not know what PR is, right? I do not know yet. Therefore, I need to calculate PR. And to calculate PR, we will not need to form another right angle triangle, this time around from the top view. So if we look from top view, from PR, we know that PR and Q actually form a right angle triangle from the top view. So we can do that, right? So when we do that and we mark down the measurements, we can see that actually we can it's a right angle triangle, and we can make use of Pythagoras theorem right here to calculate PR as 13. So now that we calculate PR, right, over here 13, then we can go back to our VPR, which is this diagram, and do the necessary calculations to actually get the angle, right? So it is more than one step. Sometimes you need to draw more than one right angle triangle to finally get the solution that you want. So that's exactly what's happening over here, right? Okay, so here's another example. This time around is a cube. I mean, again, we know that cube has right angles everywhere, right? So we are also told that M and N are midpoints. Okay, sure, they are midpoints. So we want to find MEN. So I'm going to draw the triangle MEN, right? So there we go. Sketch it out, okay? And we can see that the measurements are there. So with the measurements there quite clear, we can go ahead and get our ratio and get our angle, the desired angle, right? Now for part 2, we want to find EMN. So EMN, this time around you find that the triangle is like hanging in the middle of the cube. So sometimes if we just rely on the three-dimensional diagram, it's really quite difficult to visualize, right? So there are two methods that's recommended by the textbook, okay? But if we were to just do a quick sketch, okay, we have oh wait, it is the same right angle triangle that we have already drawn, so we don't have to repeat it, right? So EMN. So now we want to find the EMN, which is this angle over here. Okay, so in this particular case, because the angle, this diagram it works for the second part of the question. We don't have to re-sketch, but we can still use the same diagram and have a clear visual of what we're trying to achieve here, right? So of course, we have the two length, the opposite adjacent. We can use tangent, right? Alternatively, you can see that right angle triangle, regardless of what triangles, we already found this angle. We can use the angle sum of triangle, which is the method 2, right? So either case is fine. Okay, now let's take a look at part 3. Part 3 of the question asks us to find MEF. So MEF, I need the triangle as well, right? So MEF is the triangle is right here. This is a triangle that's being sketched. So I have this triangle, and I can put in the information I need. So what happened is after putting all the information that I already have, I can see that the angle I want can easily be obtained from the alternate angles, right? Because this is parallel to this. So that's exactly how I'm going to do that. Okay. And finally, part 4 of the question, let's see what they want. They want us to find HBD. So HBD, you can see, even without redrawing it, HD we can find. DB, we don't really know what is DB yet, right? Because I need a top view of the object to actually calculate DB. And do we know HB? Again, we do not have HB, right? So it's quite challenging. So we need more information. So what we can do is this is actually how diagram look like. I don't expect you to sketch this, right? This is a bit more challenging. We can actually sketch in 2D form. I will sort of expect this diagram, and then from here we can find DB first, right? After we find DB for the first part of the question, then we can go ahead and find the HB, right? So we can do this. We will find that this is HDB, right? This triangle. So we start from here. We want to find this angle, right? This right angle. So we know that it's tan. This is tan. So using Pythagoras theorem, this is what dB is. Okay, and then we look at this diagram again. Now we know that this is square root of 200, and then HD we know that it's 10 units. So from here we can use our tangent, and we can actually find the angle that we desire. So some sketchings help with 3-dimensional object. All right. So now it's practice time. So pause the video and try out the questions. So once you're done, we will unpause and we will compare our answers, right? And we're back. Okay, so here's the question. The figure shows a wedge, okay, with the horizontal base and the vertical face, and all the things are labeled there for us, right? You can read them through. So what I want to do now is we want to find angle BAC. So BAC, you can see that they are all on the same plane. So I can actually do a quick look at the top-down view, right? So I draw A, B, C, D, right? So BAC is this angle that I'm interested in. This angle I'm interested in. Do we have any information? Yes, I know that this is 15 units. I know that this is 24 units. This is 90 degrees. Okay, so from here we can have a tangent. BAC is equals to 24 over 15. Therefore, angle BAC will be the tangent inverse. Let me pull out my calculator. Tangent inverse of 24 over 15. And that will give us 57.99, which is 58.0 degrees when rounded off to 1 decimal places. Right? So that's the first part. For the second part, let's label it first part. Second part, we want to find angle CDQ. So same thing, I'm going to sketch the diagram CDQ. Right, Q is up here, C is up here, 90 degrees, D here. So I know that this is 15 units, this is 8 units. So again, by sketching the diagram, it gives us a lot of clarity of what I want to achieve, right? So from here, tangent angle CDQ is 8 over 15. So angle C, let me try to improve my handwriting. CDQ will be tangent inverse of 8 over 15, which gives us 28.1 degrees, 1 decimal places. Okay. So next, we want to find the angle AQC. So if I look at AQC, again, let's do a quick sketch. Look something like this. A is here, Q is here, C is here. We know that this is 8 units. AQC is this angle, right? However, that's all the information we have, right? So what we need to do is we need to find AC. So in order to find AC, I go back to the first diagram again, this diagram, right? Let's mark it in green. We go back to this diagram again. So in part 3, I need to find AC first, right? So to find AC, I can use, I can use Pythagoras theorem. AC square is actually equals to 15 square plus 24 square, which tells us that AC is actually equals to, let me use my calculator and work it out. Okay, it will be the square root of 801, right? So that's AC. Therefore, okay, to find this angle, AQC, tangent angle AQC is equals to square root of 801 over 8, right? Angle AQC will be equals to tangent inverse of that. So square root of 801 divided by 8, and the inverse tangent of that is 74.2 degrees, right? So that's how we work out this type of question. Okay, we have one more example. Let's take a look at this. Here we have a rectangular block of sugar with a horizontal base, right? The corners are there, so the measurements are all written for us, and we want to find angle DGH. So again, the first thing I'm going to do is draw the triangle DGH, right? So DGH, it will look something like this. This is 4 units, 6 units, D, H here, G here. So we're interested in this angle, right? So again, we can go tangent. DGH is actually equals to 4 over 6. So angle DGH with tangent inverse of that. Let's use a calculator. And that will give us 33.7 degrees, 1 decimal place, right? Right, part 2, we want to find HF. So HF is on the surface, so I will take a look at the top view. Let's sketch that. H, G, F, E this way. HF is the diagonal here. This is 90 degrees, 8 units, 6 units, right? So part 2, okay, using Pythagoras theorem, HF square is equals to 6 square plus 8 square, right? So HF will be equals to 6 square plus 8, 6 square plus 8 square is 100. So square root of that will be 10 units. The units is in centimeter. Okay, let's write it down. Okay, so we got that. Okay, and part 3, this time round we want DFH. So same thing, I'm going to sketch DFH. DFH. So if I sketch that, D here, H here, F is over here. We know that this is 4 units, and that's all the information we have, right? Oh, we have HF, right? We have HF. We have found it. So this question actually help you, it's careful for you, right? HF is actually 10 units. So we want to find angle DFH, this angle. So part 3, tangent angle DFH is equals to 4 over 10. So angle DFH will be the tangent inverse of that. So let's use the calculator to work it out. We get 21.8 degrees, 1 dp, right? There. So to conclude, when we are dealing with 3-dimensional object and 3-dimensional space, the tip is deconstruct it, right? Computational thinking, yeah? Decompose it, into two-dimensional views, and from there we can label the units and the measurements we already know, and then after that we can find the unknowns that we need. That's how we go about handling this kind of problem. Right, hope you have been successful. Have a nice day.